So in section 1.2, we're going to continue working with limits, but now we're going to find limits using algebra. And for me, I like this better. We're not going to need to do a table, not going to need to look at a graph, but we're going to be given a function without a graph, without a table, and be asked to find the limit. And generally, the first step to algebraically find a limit in this section is just to take the number that's the value of x that you're trying to find the limit at and plug it into the function. If you get a real number, it means you get something that's not an I nor undefined, then that value, when you plug that x value into the function, is the limit. If when you're doing the algebra of plugging the number in to seeing, to try to figure out the limit, if the algebra produces the fraction 0 over 0, the limit likely exists and there's algebra that needs to be done to find the limit. If plugging the number into the function gives me a fraction that has a non-zero number in the numerator and 0 in the denominator, then the limit likely doesn't exist. So here's an example. Find the limit, two-sided limit, as opposed to doing a left-hand limit and a right-hand limit separately, seeing that they equal to the same number and calling that the two-sided limit. We can go directly to what the two-sided limit is, and if all you can do to see what the two-sided limit is, just take the value that's provided, plug it in for the x, and when I plug it in for the x, I stop writing the word limit, and just do the algebra. The algebra here is just orders of operations. The 3 times 5 is 15. Then I have 15 minus 9, which is 6. Since this isn't undefined, if when I plug the number in, I get a real number, that's what the limit is. So the limit as x approaches 5 of the function 3x minus 9 is going to be 6, because when I plugged 5 in, I got 6 out. I didn't get a fraction or any number that was undefined or a non-real answer. If I kicked up the difficulty and put a fraction on the screen, well, fractions are when bad things happen. So if I wanted to find the limit as x approaches 1 of the fraction x minus 1 over x squared plus x minus 2, the first step I should try to find any limit using algebra is just to plug the numbers in. The numerator here, when I plug it in, I get 1 minus 1, which is 0. The denominator, I get 1 plus 1, because the 1 squared is 1, minus 2. The denominator also comes out to 0. If when you plug the number in that you're asked the value of x that you want to find the limit at, if when you plug it in you get 0 over 0, the limit usually exists. And in this section, there's just a couple techniques that we're going to learn to pull out the limit when the limit probably exists, but plugging the number in doesn't work. And in this case, the algebra that I'm going to need to do is to factor the denominator, and that factoring, if I factor right, is going to lead to canceling and allow me to plug the number in. So that's what I've done here. I've factored the denominator. This denominator factors into x minus 1 times x plus 2. So your factoring skills don't need to be fantastic in our class, but this basic factoring you need to be able to do. If you can't, in my intermediate algebra, I think section 5.3, I teach you how to factor this kind of problem. So the factoring, when you get 0 over 0, is bound to lead to some canceling. And when I do the canceling, the x minus 1s that I cancel turn to 1. So the numerator is going to be a 1. The denominator is 1 times x plus 2 when I cancel, which is just x plus 2. So when I get 0 over 0 in a fraction that has a factorable denominator, I factor the denominator, I cancel, and then I plug the number in again. So now I'm going to take the number and plug it in. The number that I'm asked to plug in for x is 1. So I'm going to plug 1 in. And when I plug 1 in, now I don't get 0 over 0. That's what this limit's going to be. The answer to the limit as x approaches 1 of this fraction is 1/3. The ugly thing is this next problem. So how do I find a limit of this ugly fraction that has a square root in the numerator? Well, anytime I'm asked to find the limit, I should take the value that's given to me and plug it in for x. Fractions are not our friends in this section. So the value that was given to me, I'm trying to find the limit as x approaches 4 of the fraction square root of x minus 2 over x minus 4. Let me plug the 4 in. That's always the first step in calculating any limit of a number that's not infinity. So I plugged in 4, the value that I'm finding the limit at, and I got 0 over 0. So the limit likely exists, but there's no way I could factor that denominator. So there's another strategy, and this is the other strategy for when I get 0 over 0 finding the limits of a fraction. There's the other algebra I'm going to need to do is to multiply by the conjugate of the numerator, FOIL and simplify the numerator, do not FOIL or simplify the denominator, cancel and plug in. I have this all typed up on another screen, but I'm going to write it so you can see it fresh. So what am I going to do to find this limit? I'm going to multiply by the conjugate of the numerator. The conjugate of the numerator is the numerator with its sign changed. And what I mean by multiplying by the conjugate of the numerator, if I could actually do that properly, is to multiply both the numerator and the denominator by the same conjugate. If I multiply a fraction by the numerator and the denominator of a fraction by the same expression, then I just change what the fraction looks like, but not what it equals to. I can't even write this down. So I'm going to multiply the numerator by its conjugate. The conjugate of the square root of x minus 2 is the square root of x plus 2. And in this denominator that hardly looks like x minus 4, I'm also going to multiply it by the square root of x plus 2. So anytime I get 0 over 0, the limit likely exists. Factoring and canceling isn't an option. There's no factoring that can be done. In these square root problems, I multiply by the conjugate of the numerator. I'm going to FOIL the numerator but not the denominator. So for my next step, I'm going to leave the denominator in its unfactored, unmultiplied version. The denominator right now is x minus 4 times the square root of x plus 2. I'm going to FOIL out the numerator and write it right there. So for the numerator, I need to do firsts, which are the square root of x times the square root of x. Anytime you multiply two identical square roots, it simplifies to what's under one of the square roots or both of the square roots without the square root symbol. So square root of x times the square root of x is just x. And then outers, the square root of x times 2, that's just positive 2 square root of x. And then inners, minus 2 times square root of x, that's just minus 2 square root of x. And lasts, minus 2 times positive 2, that's minus 4. So that's FOILing, simplifying the numerator. So I FOILed the numerator. I'm going to simplify by canceling out those square roots of 2 square root of x's. And in the numerator, what I'm left with is x minus 4. So first step was multiplying numerator and the denominator by the conjugate. Second step, I FOILed and simplified the numerator off to the side and wrote the simplified version in the numerator. I do not FOIL nor simplify the denominator. Now I'm going to cancel. Now these x minus 4s can cancel. And when I cancel them, I can't write a fraction without a numerator. So I'm going to write a 1 in the numerator of my fraction, and then the square root of x plus 2 in the denominator. So multiply by the conjugate, simplify the numerator, did nothing to the denominator, canceled. Now I'm at the point where I can plug in 4 again. And when I plug in 4, I don't write the word limit anymore. Actually, it's called taking the limit when I plug the number in. So this is going to give me 1 over the square root of 4 plus 2, which is 1 over 2 plus 2, which is 1 over 4. That's the answer to question 3, the limit as x approaches 4 of the fraction square root of x minus 2 over x minus 4 equals 1/4. When I write my answer, I'd probably just write the number 1/4 rather than showing, the whole problem with the answer, but that's the proper way to do it. So those are limits when the x isn't infinity. The algebra is different when the x is infinity, and it's a little bit kind of funky when the x is infinity, but let me try to show it. So if I want to find the limit as x approaches infinity of this fraction, well, let me plug infinity in for x. I get 2 times infinity plus 1 over 5 plus infinity plus 4. We never do math with infinity. 2 times infinity is still equal to infinity. That's something, that I learned in grad school, but that's hardly believable. But it is. There's only several different infinities. And for what it's worth, this right here, this numerator is equivalent to infinity. This denominator is equivalent to infinity. If you get infinity over infinity, the limit may exist. It may not exist. This step is kind of useless. In fact, this step of plugging in infinity when the limit's at infinity, it's a worthless step for the most part. And I should probably skip it consistently. When I'm asked to find the limit of a fraction at infinity, I examine all the x terms. The x term in the numerator has a first power. The x term in the denominator has a first power. What I should do is rewrite the problem so that all the x's are buried in the denominator of the fractions. And this will allow me to use something I'll talk about when it becomes important. A fraction with a number over infinity is equal to 0. So let me do this. I'm going to take the whole fraction. And again, let me just do this. I have it typed up here, but I want to do it by hand. So when the limit's at infinity, plugging in infinity is generally worthless. It's never going to give me anything that I can think is productive. What I'm going to do is multiply the entire numerator by 1 over the highest power of x that occurs in either the numerator or the denominator. In this case, the highest power of x term in the numerator is x to the first. The highest power of the x term in the denominator was also x to the first. So I multiply the numerator and the denominator by 1 over x. I've multiplied by something that's equivalent to 1. 1 over x divided by 1 over x, I've multiplied by 1. Let me do this multiplication now. I'm going to clear the parentheses in the numerator. In the numerator, I need to go 1 over x times 2x and 1 over x times 1 to clear my parentheses. In the denominator, to clear the parentheses that I put in, I go 1 over x times 5x plus 1 over x times 1. These x's in the denominators of the fractions next to the x terms in the numerators cancel. And this is going to leave me with the limit as x goes to infinity of 1 times 2, fraction is gone, 2, plus anything times 1 is 1, so plus 1 over x. Should be a 5x plus 4 here. I didn't write down the number right. That 1 that I wrote should be a 4, which makes this should be a 4. This is a forgiving mistake because I would have gotten the right answer if I didn't catch it. This right here, the x's cancel. I'm left with 1 times 5, which is 5. And for this one, I'm left with 1 times 4 over x, or 4 over x. So once I get every x buried in the denominator of a fraction, this is when I can plug infinity in and have it be productive. So I'm going to say this limit is 2 plus 1 over infinity divided by 5 plus 4 over infinity. Any fraction with an integer in the numerator, infinity and infinity in the denominator is equivalent to 0. This is like saying take the number 1 and divide it into infinitely many parts. Well, then each part is essentially size 0. So 1 over infinity we say is equivalent to 0. Similarly, in the denominator, if you take the number 4 and divide it into infinitely many parts, each piece is about width 0 or dimension 0. So any fraction with an integer, or even a fraction in the numerator and 0 in the denominator, is equivalent to 0. And so the limit for this is going to be 2/5. My answer to the limit as x approaches infinity of the fraction 2x plus 1 over 5x plus 4 is 2/5. There's tricks to this that you learn in algebra that might be useful, but I won't talk about them right yet. I want to do the math properly without tricks at this point. Last one is I'm finding a limit at infinity for a polynomial. This there's no algebra for. When I do the limit of a polynomial, this is not a non-fraction, the limit's either going to be positive or negative infinity, and that depends on what the graph looks like, or depends on what a table looks like, or it depends on how I can logic it out. So this limit, I sketched the graph right here. This is the graph of f of x equals negative 3x plus 4. It's actually the graph of f of x equals negative 3x. I don't know why I got so heady here. But anyways, this graph, let me just graph it on this calculator. This is getting silly. This is not that important of a skill. So let me sketch the graph of negative 3x plus 4. Go to a zoom standard. And these graphs are not going to stabilize. And since I'm going for the limit as x goes to positive infinity, to the right of the y-axis, the graph goes down. And that goes down to the bottom of the y-axis. The bottom of the y-axis has an x-coordinate or y-coordinate of negative infinity. And we'll dump out anything I wrote here. This is just too heady for something that's not that important. So for a polynomial, the limit at infinity is never going to exist. It's either going to be a negative or positive infinity. And we'll just sketch a graph and determine if the graph is going up or down to figure out if it's a negative or positive infinity. So now that's all the theory. Now we can just jump into doing some homework. There are apparently about 37 problems in this section, so we'll split this video into 2 sections. I'm going to do a bunch of even problems. My first limit wants me to find the limit as x approaches negative 3 of the function 5x minus 7. And anytime I'm given a number that's not infinity, and I'm asked to find the limit at that number, algebraically I just plug the number in. If I don't get something that's undefined, and I get just a nice real number, that real number is what the limit is. So I'm just doing orders of operations now. And my orders of operations gives me the number negative 22. That's the answer to problem 2. I don't need to write the problem next to the answer like I did down here. The limit is negative 22. For problems 3 and 4, they work the same way. It's a limit of a polynomial not at infinity. If it was at infinity, I would graph it and figure out what the limit is. But in this section, for each problem that I'm asked to find the limit of, if the number here isn't infinity, then I'm going to do the algebra of plugging the number in. And if when I plug the number in, I get something that's not a undefined or does not exist, then that's what the limit is. So my answer to problem 4, the limit is going to be negative 9. Even square roots can work out. For number 6, to find the limit as x approaches negative 3 of 2x minus 10, I'm simply going to plug in negative 3 for x and hope I don't get something that's ugly. Do the orders of operations. Under the square root, 2 times negative 3 is negative 6. And then under the square root, negative 6 plus 10 is 4. The square root of 4 is 2. Since that's a nice real number, the answer to number 6, the limit is just 2. In the world of fractions, I have the danger of getting 0 over 0. If I get 0 over 0, the limit likely exists, but I have to do algebra. But for 8, I'm asked to find the limit as x approaches 4 of this fraction. So I'm just going to plug in 4 and see what happens. The numerator comes out to 8 plus 1. The denominator comes out to be, this should be 4 plus 7. I don't know why I'm not carrying the number so well, but that's going to happen often. The denominator comes out to 11 after I fix it to make it 4 plus 7. The numerator comes out to 9. That's not 0 over 0. That's what the limit is for number 8. So anytime I can plug the number in and get something that is just a nice real number, that's what the limit is. For problem 10, I'm asked to find the limit as x approaches 1 of the fraction x squared plus 4x minus 5 over x squared minus 1. I think this is a 0 over 0 because the numerator comes out to 1 squared, which is 1, plus 4 times 1, which is 4, minus 5. The denominator comes out to 1 minus 1. This is 0 over 0. There's only 2 strategies that we teach for finding limits of fractions when the x isn't infinity. It's either factoring and canceling or multiplying by the conjugate. I factor and cancel if something can be factored, and both the numerator and the denominator can be factored. Because I got 0 over 0 for my algebra, the limit probably exists. And to figure out what the limit is, I need to factor anything that can be factored. Hopefully your factoring skills are good enough that when I factor this and say this is x plus 5 times x minus 1, that doesn't leave you, stumped. If not, if you can't factor something this basic, you gotta get that factoring skill beefed up, because you gotta be able to factor just basic factoring. I don't think I put much of all hard factoring. The denominator is the difference of squares. It factors into x plus and x minus 1. So when I factored, I produced duplicate factors of x minus 1. That's a good thing, because now I could cancel out those x minus 1s and get the fraction x plus 5 over x plus 1. And now I can plug the 1 in and have it be harmless. This is going to give me 6 in the numerator when I plug in 1 for the x, 2 in for the denominator when I plug in 1 for x, and 6 over 2 is 3. I typed up the answer here, but you certainly don't need to write the problem with the answer. It's enough just to write the number 3. So if this was a test and I only wrote the number 3, that would be fine for the answer. You need to show the algebra to get the answer, but you don't need to write the word limit with your answer. For number 12, I'm going to plug in the value of x that I'm asked to evaluate it, which is negative 2, and do negative 2 squared minus 4 over negative 2 squared minus 3 times negative 2 plus 2. When you square a negative number, you get positive, so negative 2 squared is positive 4. The numerator simplifies to 4 minus 4. The denominator, negative 2 squared, is positive 4. Negative 3 times negative 2 is positive 6. And plus 2 is plus 2. Whoa. Here I get 0 over 12. I think the limit is just 0. Let me sketch a graph of this. It surprises me. Let me put the function x squared minus 4 in. X squared minus 4 divided by x squared minus 3x plus 2. And let me try to plug negative 2 in. So do second calc value. My calculator is going to plug negative 2 in for me to make sure I get 0. Negative 2. Yeah, it is 0. So the limit is 0. Let's do 11 because I don't think this is what I want it to have happen. So let's work on 11 since it's on this page. For 11, I want to find the limit as x approaches 3 of that fraction. So I'm going to plug in 3 for the x in the numerator and 3 for both x's in the denominator. The numerator becomes 9 minus 9 because the 3 squared is 9. The denominator becomes 9 minus 12 plus 3. And the 9 minus 12 plus 3 in the denominator is 0. The numerator, 9 minus 9, is clearly 0. And the denominator also comes out to 0. So the limit likely exists, but I need to do algebra. To do problem 11 algebraically, I'm going to factor the numerator and factor the denominator. The numerator, x squared minus 9, is easy factoring. It factors into x plus 3 and x minus 3. The denominator, by this point in your algebra career, has got to be easy factoring. This is, if you cannot factor these, we need to sit together and work on your factoring, or you need to watch some videos or just get some help. This can't be hard. Otherwise, then the calculus gets ridiculous. So you have to have some basic skills, and simple factoring is a skill that everybody needs to have at this point. That denominator factors into x minus 1 times x minus 3. Now I can cancel the x minus 3's, and in problem 11, I can rewrite this as a limit as x approaches 3 of x plus 3 minus over x minus 1. Now I make my shot at plugging 3 in, and I get 3 plus 3 over 3 minus 1. That's going to be 6 over 2, and the answer to number 11 is just going to be 3. Ooh, hard factoring. This factoring you should be rusty on. And I won't put this kind of factoring on a test, at least I don't think I do, but I'll do the factoring for you anyways. So in problem 14, I'm going to assume I get 0 over 0. Just to save a minute, I'm going to assume that I get 0 over 0 when I plug in 3. And I'm going to try to factor 2x squared minus 7x plus 3. Some of you might factor in your head, which I would love. Some of you might use bottoms up, which is completely fine. I teach now rewriting with 4 terms and factoring by grouping. I multiply this 2 and this 3 and get 6. And I need numbers that multiply to 6 and add to negative 7. And that's negative 6 and negative 1, because negative 6 plus negative 1 adds to negative 7. Negative 6 times negative 1 multiplies to positive 6. So I'm going to rewrite the negative 7x as negative 1x plus negative 6x and factor by grouping. So the problem, 2x squared minus 7x plus 3, well, I just committed to doing it backwards. Doesn't matter. I need to rewrite the 7x with a 6x and a 1x, and then factor by grouping. Split to a left half and a right half. Pull out a common factor here. Pull out a common factor here. In the first pair, there's a common factor of 2x that I could factor out. When I factor out a 2x, I'm left with an x minus 3. After this vertical bar, I'm going to factor out a common factor of a negative 1 and be left with another x minus 3. That's going to give me the common factor of x minus 3 times 2x minus 1, what's in front of the common factors when I go to factor the numerator in problem 14. So the numerator factors into x minus 3 times 2x minus 1. You don't have to use the grouping method. It's just a method that I've started teaching recently, and seems to work just fine. And now I'm going to factor 3x squared minus 7x minus 6. I multiply the 3 and the minus 6 and get minus 18. I'm looking for numbers that multiply to minus 18, that add but really subtract to negative 7. And that's going to be 2 and negative 9, because 2 times negative 9, if you multiply those, you get negative 18. And 2 plus negative 9, if you add those, you get negative 7. What I'm going to do with the negative 7x in my problem is I'm going to rewrite it as negative 9x plus positive 2x. So I'm going to take my problem, rewrite it with 4 terms. If there's a negative and a positive, it's well worth your time to put the negative first and the positive second. So in my efforts to factor that, one strategy that works is factoring by grouping. You take the problem, you rewrite it as 4 terms, and then you common factor. My first factoring, I'm going to factor out a 3x and be left with an x minus 3. My second factoring, I'm going to factor out a 2 and be left with an x minus 3. So hopefully, if this is the way that you learned how to factor, me doing 2 examples was enough for you to remember that skill, and you don't have to review it. If it's not enough, or if you learned a different strategy, this probably won't come on the test, ugly factoring like this, but it's good to know. So I've factored both the numerator and the denominator. Now that I have both the numerator and the denominator factored, I see the common factor of x minus 3, they're going to cancel. That's going to leave me with the limit as x approaches 3 of 2x minus 1 over 3x plus 2. I didn't actually plug in the 3, but I'm pretty sure you'd get 0 over 0. Now I'm going to take the time to plug in 3 when I know I'm not going to get 0 over 0. I didn't plug it in at first just because I wanted to save a minute, but you should plug it in. So when I plug in 3 in the numerator, I'm left with 6 minus 1. When I plug in 3 in the denominator, I'm left with 9 plus 2. My answer for number 14 is going to be 5 over 11. I should make sure. Haha, I did this in my head, but I shall see if it's correct. I don't think it's correct. I think it's 5 over 11. Let me just check real quickly that I factored right. That's factored right. Yeah, 5 over 11 feels better than the answer that I had written down. So this is probably a safe stopping point before we can move on to a part 2, because the next kind of problems are a new kind of problem. Well, we did one in the examples, but we haven't done them in the homeworks. So I'm going to move on to do a part 2, and I think there will only be 2 parts to this section.